This is the Math 1401 Zoom meeting for March 11th, 9 p.m. And just work a few problems here. We haven't worked, I haven't shown you one like 21. Oh, we have a participant. Yes. Do you have any questions tonight?
Yes, I did. I just saw the result you released.
Right.
It's like I made a mistake. I thought it was to enter just the capital T and capital F. So the results show that I have 0 on 100.
Right. Yeah, it's exactly, all the responses work the same way. And I clearly said it out in the email. Type out the word true, type out the word false and capitalize. It should look exactly like this. On a true one, it should look like this. And on a false one, it should look like this. That's exactly the way you enter on the quizzes. And
yes, yeah. But when I saw on top of it that type only capital, only T and F capitalized, I got confused. So I was typing just the first letters on the answer sheet.
Right, but I did say type out the entire word. See, what happens is people will do this or this, and the computer will mark this wrong. So that's why I said type out the word, but only capitalize the T or the F. So I'll tell you what, send me via email your responses just like this, 1 T, 2, you don't have to type it out when you do it by email because I'm doing it by hand, F, 3, whatever it is, okay?
Okay, thank you.
Just send it in to me by email and I'll grade it by hand.
Thank you.
Okay, sure thing. Yeah, it's going to work that way from now on. We're no more D2L where you click on the word. We're through with that.
Okay.
We have another participant. You have any questions tonight? I can't see your name.
I think it should be Lisa.
Okay.
Yeah, it's Lisa.
Oh, okay. Do you have any questions tonight?
No, not that I can think of. Not right now. I just really got in, so.
Okay. Well, what do y'all want to do? Anybody want to see any problems worked?
I like to have some work, yes.
Okay, sure thing. Which ones?
Oh my goodness. Obase, do you have any questions or any problems?
No, please. I did during the day. The ones that I was having problem with. But I don't mind if Mr. C can take us through 6.1. Any problem in 6.1? Thank you.
Well, okay, I hadn't shown one like 21 here. This is the number of games played in the World Series from 1923 to 2014. That's the championship series of baseball, if you all are familiar with baseball. And you have to win 4 out of 7 games to win the World Series and be the champion of the baseball league. And so what they've done pretty much out of chapter 2, this is 6.1, page 306. Problem 21, X is the games played. I don't know if you all follow enough baseball to know, but it's gone 4 games, 5 games, 6 games, and 7 games. So 4 is the minimum number of games. This is the frequency. It's gone that way 18 times. 18 times, it's also gone 5 games. 20 times, it's gone 6 games. In 35, it's gone all 7 games, which means basically it wound up somebody winning it 4-3, win 4 games and lost 3 of it. So part A is construct your probability distribution. Construct a discrete probability distribution. Now they're giving you this gibberish formula, and basically what they're saying is, just like we did in chapter 2, got to total this up. Let's see, 18 is 36, 20 is 76 plus 35. Maybe I'll just do it all at once. 18 plus 18 plus 20 plus 35. 91 times the World Series has been played of baseball. And remember, you got a relative frequency. So we're going to divide each of these by that total, 91. So 18 divided by 91 comes up 0.197. We'll call it 0.2. Next would be 0.2 as well. 20 will be just a little bigger, divided by 91. 219, let's call that 22. 197. Then 35 divided by 91, 38.38. 38% of the time it's gone all 4 games. So part A, your probability distribution, you pick out the X column and this relative frequency and call it P of X. So X, instead of most of these ones in this chapter have gone 0, 1, 2, 3, but that wouldn't apply to the World Series number of games played. So it starts at 4, 5, 6, and 7, and then the P of X is 0.2, 0.2, 0.22, and 0.38. So basically, anytime or in the future, you want to know your chance of the World Series going all 7 games, it looks like it'd be about 38% chance that the World Series would go all 7 games. Any questions so far?
No, please.
Okay.
No.
All right. So B is draw a graph. Easiest way to do that is by hand. 1, 2, 3. I could bring the 4 back here. You can do it however you want. I guess I'll just 5, 6, and 7. And then 0.1, 0.2, 0.3, 0.4. And so, yeah, 4 games and you're up 0.2. 5 games, you're at 0.2. 6 games, you're at 0.22, slightly bigger. 7 games, you're up to 0.38, almost 0.4, something like that. You could theoretically draw this on the calculator. It would probably take 20 minutes to get all the settings right and explain how to do it. You can knock it out in 30 seconds. Questions about that?
Well, with that example, will you use something like that on the quiz this week?
Well, yeah, it might appear.
Okay.
So I would have a graph drawn because I got no way to collect a graph from you. And then of course, it'd be true or false. Is this a good graph? If you just say, yes, it's a correct graph, then it'd be true. The problem is correct. And if it's, if I messed it up, then it would be false. It's, not a good graph. So if we go to part C and they say compute the mean. Have we gotten it across that your mean is basically a dance X times the P of X, X times the P of X, add them up. Use this symbol, and that means sum X times P of X, which means you go 4 times 0.2. 5 times 0.2, 6 times 0.2, 7 times 0.38. This will be the average number of games the World Series has gone. 0.2, 5 times 0.2, 6 times 0.22, 7 times 0.38. 5.78 games. And D is the standard deviation. I did one by hand, I believe, on Monday's video. I'm not sure if y'all have the stomach for it. If you remember, I showed everybody how to enter this in L1, the X in L1. I don't know how that, oh, we've got more participants here. Mr. Augustine's again, okay. And the P of X in L2. And I showed how to get the standard deviation off the calculator. Do y'all want to do it that way? Or do you want to see it painfully done by hand?
I like the calculator, but
Okay.
others may want to be done by hand. I don't know.
Well, the mean isn't that bad to do by hand. If you got, we had only four numbers. It wasn't that bad. Yeah, it would take another, 2-3 minutes to do it by hand. I'll try to keep both on the screen here if I can. But I'm going to enter this in L1 and this in L2. Stat, edit. I'm going to clear up to the top label, clear and down. Did this in chapter 3, up to the top label, clear and down. L1's pretty simple, 4, 5, 6, 7. All right. L2, 0.2, 0.2, 0.22, 0.38. Are y'all out there entering? Y'all still entering or?
I'm done.
Done, okay. So you have to tell the calculator to do the dance, bring in both. Now the mean is the direct dance. There's more operations in the standard deviation, but I'll write out the directions. You want to go stat, calc, one variable, stats. It's option number 1. Do not hit enter here. You do, you'll get numbers and they'll be wrong. This is what we did in chapter 3 when we only had an L1 column. On mine, I've got to go L1 comma L2. You may have the newer calculator where you have your L1 on one row, you enter your L2 on the next row, it'll be a calculate row. That's what they do. They enter them on separate rows in the newer interface. This is the newer one. I hope this makes sense. This is, again, a little, we're teaching on this online isn't the greatest. If I don't have a calculator that directly matches y'all's. All right, so let's see, stat and edit. I got all the numbers in. All right, so I go stat, calc, hit enter on one variable stats. Okay, but I don't hit enter again. That'd give me chapter 3 numbers, and that's not what I want. I have to go L1 comma L2. Now you, again, may be able to do this on separate rows. So see if you can puzzle that out and see if you get these numbers. There's my 5.78 for the mean. Mean comes up first at 5.78. There it is. And your standard deviation, they label it sigma x on this, is 1 point, we'll call it 154. Did anybody have any questions about that, or did you want an instant replay?
I don't have a question.
I'm wondering, where do you find the comma on your calculator?
It's above 7.
Ah, I see it. I got it.
It's a separate key above 7 there.
Okay.
Like I say, that's the old, this calculator is probably 15 years old.
It's the same place on mine.
Oh, okay. Yeah, they've made the newer ones much nicer. So that was all for problem 21. That's all they wanted. Did anyone want to see any others? We worked basically a similar one to 23 at 12 o'clock today and a similar one to 25. And we even did 27, the blackjack problem. It's got a lot of words. It's really simple problem, but they give you an entire lecture on playing blackjack. Which we all cannot go down to all our open Georgia casinos and find our local blackjack game. Did anybody want to see an instant replay on any of those? Or we didn't do 29s about roulette. And 31 is about Powerball. A lot of numbers and decimals in Powerball there in 31. Anybody want to see any of those?
No one's talking, but I wouldn't mind saying 31.
31.
That's the Powerball one?
Yes,
That's
please.
the Powerball.
Okay.
Okay, this is a multi-state lottery. So I don't think you can play this in Georgia either. I believe the only legal form of gambling in Georgia is the Georgia Lotto. Now that doesn't mean you can't send money out of state to somebody where they're playing a multi-state lottery and buy a ticket and win. But they give you the table here. I won't copy it down. And the only thing to remember, they just give you grand prize here. And then they tell you part A, the grand prize, 15 million. So really you want to be putting in 15 million right there under grand prize. And you can see the incredibly high probability of winning that 15 million. You see that? And what's the chance, the most likely outcome? Well, you come down, cash prize of 0. Take a look. What's the chance of winning Bupkis?
97%.
97% chance you win nothing. That make you want to go out and bet your baby's milk money on the lottery? Or your mortgage money? Hey,
No.
I think I'll pay my mortgage this month, or I think I'll buy a bunch of lottery tickets. I wonder what's more, win the lottery and then I can buy my house outright. I don't have to keep making these stupid mortgage payments. Okay. 31A, they say expected cash prize. Well, the word expected means mean. Cash prize. Expected value, they use that language in some of these problems, and it means mean. Now, I won't recopy the entire table. I'll put in 15 million for the grand prize, maybe do one other row. 200,000 is the next prize. And the probability is how many zeros is that? I'm going blind. 1, 2, 3, 4, 5, 6, 7. That's 8 zeros. 5, 6, 7, 8, 6, 8, 4. The next one has 1, 2, 3, 4, 5, 6 zeros. 4, 5, 6, 2, 8, and then it goes on down. So basically want us to find the mean. Now, again, we could do it out by hand, 15 million times this, 200,000 times this, and do that dance all the way down. Or we can do it the way we just did, the last problem is enter these in L1 and L2, and then run through the keys and have the calculator tell us the mean. You want to do it that way? Everybody's so in awe, everybody's speechless. Oh, just enter them in the calculator?
I said yes.
Okay,
Yes, sir.
sounds good. So we got 15, that's gonna be a bunch of zeros. 3 of them is 15,000, but we want 3 more, which is 15 million. And notice it enters it in scientific notation. Because it's so long, you can't show it in the cell. 200,000. Got it. 10,000. 100. 7. Look at the chance. There's like 0.4% chance of even winning $7. 4, 3, and 0. So there's the L1 column, all the different amounts in this lottery you could win. All right, let's see if I can enter all the only nasty thing about this is these nasty numbers. Otherwise, it's a really simple problem. It's just because they give you the table, it's just a lot of nasty numbers to enter. That was 8 zeros. Point 1, 2, 3, 4, 5, 6, 7, 8, 6, 8, 4. And you can see the scientific notation there. 6.8 E minus 9. Next one had 6 zeros. 0.1, 2, 3, 4, 5, 6, 2, 8. Again, scientific notation. Next one I think has got 5 zeros. 1, 2, 3, 4, 5. 1, 7, 11. 1, 7, 1, 1. Next one's got 3 zeros. Now it's getting a little more reasonable. 3 zeros. 1, 2, 3. 1, 5, 3, 9, 9, 6. Aren't you all so glad? Again, still scientific notation. Aren't you all so glad you paid your tuition money to come out tonight and watch me enter all these nasty numbers? All right, $7. 0.004. 778. 961. $4. Look at all these. Golly, who sit down and figured all this out? 0.007. 88. 1463. $3. 0.014. 50116. 1% chance of winning $3. And finally, 0.972. 682. 4 and 3 twos. Woo! Y'all entering the numbers along with Mr. C? Or are you just watching me?
Watching.
Just watching, okay. Well, once they're entered, it's not a hard problem. Are we ready to go on and get the mean or the expected value?
Yes,
Stats,
please.
calc, one variable stats, but don't hit enter. L1 on this machine, comma, L2. Enter. Mean is 0.299. Expected. I guess we'll round it to 0.3. This means you earn 30 cents on the average. Well, that'll pay your mortgage every month, I bet. Won't even buy a candy bar. Questions about that?
No, please. It's like the question is the same as question 28.
Yeah, it's really similar to 20, is it 28? Well, yeah, kind of
Yeah,
similar, except you got,
same.
now they give you all the numbers you need in 28, but you got to puzzle them out into a table.
Yes, please.
So B, 31, let's see. No, we're still on A. To play this, you had to buy a ticket. The ticket costs $1. All right, so what is your mean profit or expected profit? Well, if you know any basic business, your profit is your revenue, money in, minus your cost, money out. Well, this is the revenue in. You're earning 30 cents, and it cost you $1 to play. Can you tell that's negative 0.7? You're losing 70 cents every time you play on the average. Okay. Yeah, you know, I don't really worry about B and C. I should have left those off. Just cross off B and cross off C. All right, questions about that, or do y'all want to see any more? Anybody want to see any more problems?
No questions from me. If you have the time, Professor, more problems always helps. That's if you have the time and if they have the patience as well.
Okay, I got that you wanted more problems, but I didn't get which ones. Can you tell me exactly which problem?
I didn't open the textbook right now. If you can choose the ones that you feel will be a little bit challenging to us.
Well,
Oh, okay.
I've worked 20.
Okay,
25 was pretty
we did.
challenging. I worked it at 12 p.m. You were there, right?
Yes, Professor.
Yeah, you had to create your table, and 2 of the numbers were obvious and 2 were not.
Yes.
Yeah, blackjack's pretty easy because they give you the full table.
Yes.
31's pretty easy because they give you the full table. It's just a little nasty entering the numbers. 29 kind of parallels 25, but the numbers are a little easier. We hadn't worked 29. You want to see it?
If it's the same with 25, then I'm good. I don't know about the others in the class.
Yeah, instead of winning and losing, or living and dying, like life insurance,
I'm
just
okay with 25 because I think Lisa needs 25.
Oh, okay. I couldn't hear. Lisa, you want 25?
No, I didn't say anything. No.
Oh, okay. All right, kind of putting your.
Okay.
Yeah, if you watch the video at 12 o'clock,
Right.
the key to it's creating the table. And 2 of the numbers are obvious and 2 are not. And 29 kind of parallels it. You win the game of roulette or you lose the game of roulette. So it's a little less stakes than living and dying, like life insurance. Life insurance was a little more dramatic. You live or you die. 29, you just win or you lose. Well, I don't want to bore the heck out of people. Anybody wanting to see more?
I'm good, Professor.
Okay.
Yes, please.
Professor, can you post, sorry, I'm asking this, if you can post more of the my lab exercise?
Well, I've tried to do that. But the thing is, MyLab scrambles the project problem so much that if I post what I see, it's not the same thing as what you see. Then the numbers get changed.
Okay.
I think the
It-
working remains the same.
Yeah, it's similar. Yeah, and you work them the similar way, but it isn't exactly the same. If it goes easier if you got a specific one you want to know about, if you can tell me what it is, I can sketch out what they give you here and work it in front of you. Have you got a specific one you'd like to know about?
No, Professor, I'm good.
Okay.
I have one, but it's from, I couldn't for the life of me get it right. It was 5.4, and I'm looking for it now.
All right. They parallel, I've noticed that they parallel a lot of the book problems, but the numbers will be changed. Do you have the specific number out of 5.4?
Yeah, I'm looking for it. I'm
Okay.
getting that. Hold on.
Professor, will the final exam be a cumulative of all the topics or just different one?
No, it is cumulative. And it'll have the same exact format. I will pass out a review sheet for the final exam. I don't have review sheets for these tests, but I do have for the final exam. It'll have
Okay,
10
sir.
problems on it, and it'll look exactly like these tests. True or false, the problem is correct, but it will cover from chapter 1 through chapter 10.
Okay.
Okay.
It's worth 10% of your grade.
Okay. And please, when is the fourth test coming up?
When it's what now?
The fourth. The fourth test coming up.
Oh, the fourth test.
Yes, please.
I don't have the calendar in front of me, but it's actually it's pretty quick.
Oh, really?
Because we're going to take a test on 6.1 and 7.2.
Okay.
So we've done 6.1 this week. There'll be a quiz tomorrow. And then 7.2 we do next week. And so, yeah, the fourth test will be the end of next week.
Okay.
Yeah.
Thank you.
Can you hear me?
Yeah, I can hear you.
I'm having a problem for some reason. Do they disappear after you work the problems, like the check marks?
It may, because if you redo it, it throws up a different problem with the different numbers, as far as I know.
Yeah, but like when you're counting them, when we send our email to you to say what we got right and stuff,
Right.
it has the check marks in there. I'm just wondering, do they disappear after a while? Because for some reason,
You're not finding the
yeah,
check
this is
marks
weird.
again? Yeah, maybe they do. If you remember how many you did, you don't have to, redo them or anything.
No, I could not for the life of me figure out how they got this answer. I should have, let me see, hold on. Let me pull up my paper. Okay, so for instance, like 5.3, 0.25, let me find that one.
Okay, 5.3.25.
Yeah, I got A and B, but for some reason I couldn't figure out how to do C or couldn't get it correct. So you get the whole problem wrong. So, but let me go back.
Is that the bowling problem?
I don't know. I was so aggravated. Let me see.
Because a lot of them do parallel what the book has.
Oh, here they are. Okay, good. Okay, I know. 5.313 was the first one that gave me problems,
Okay,
and it reads about 14% of the population of a large country is nervous around strangers. If two people are randomly selected, what is the probability both are nervous around strangers? So I got I did 0.14 to the second power or squared and got the answer.
okay.
And then the part B is, what is the probability at least one is nervous around strangers?
Or not nervous.
Huh?
Does it say 14% are nervous, right?
Yeah, 14% are nervous around strangers.
Okay.
And then part A, if two people are randomly selected, what is the probability both are nervous around strangers?
Okay.
So I got that portion correct. Then
Two.
part B says, what is the probability at least one is nervous around strangers?
Okay, it probably reads at least one is not nervous,
No,
doesn't it?
no. That's what was so, watch the videos, and I always watch the videos before I tackle these problems, and take my own personal notes. And a lot of these problems, they're not like what the book, the practice problems,
Right.
in Stat Lab. So
That's dirty to do that to you.
yeah, it is very
Because if it's at least one not nervous, that's the pattern he follows in the book, and you can
right.
track this from one.
No, it says, what is a probability at least one is nervous around strangers? Assume the events are independent.
Okay. Yeah, the only way to explain this is with a table.
Mm-hmm.
Yeah, so that's dirty to do that to you because he did not give you a complement event to this.
Right.
Okay, so here's your table, and it parallels a coin with heads and tails. But we're going to say both people could be nervous.
Mm-hmm.
Nervous, not nervous. Not nervous, nervous. Or both are not nervous. Okay, so you got the idea?
Right. Mm-hmm.
All right. At least one is nervous. That would be all the rows that have at least one in. So that's row one here. We number them row one. See, that applies to row two. And it applies to row three here, right?
Right.
Okay. And so we got to account for all three rows. Now, you've already done basically row one. This is in effect row one.
Mm-hmm.
So that's your 0.14, 0.14, your 0.0196, 96. All right, well, row two is going to go 0.14 for the nervous. And can you tell the not nervous is going to be 0.86?
Yeah, that makes sense.
Okay. And so you can multiply that out. 0.1204. Well, row three is going to be the same thing, just reversed.
Mm-hmm.
0.86 for the not nervous, 0.14 that the second person is nervous. And that, again, that would just multiply to the same thing. And so then this answer, probability at least one nervous, will be 0.0196, add 0.1204, add 0.1204. This is sort of the long way of doing it. 0.0196 plus 0.1204 plus another 0.1204, 0.2604. If you wanted to slick it up a little bit, you could have figured row four here. See, but they didn't tell you to do that. That's your 0.86 times 0.86. 0.86 squared, 7396. And then you could have done it as a complement by subtracting this from 1.
So you would subtract the 0.7396 from the 0.196?
No, from 1.
Oh, from 1.
You wanted all, see, I just did all 3 rows directly.
Yeah.
But method 2, you could have, and in fact, in the book, he would have told you to do row 4, and then you could have done the second one here as a complement. But it would go 1 minus 0.7396. And I'm sorry, delete. Okay. And there is your 0.2604. But you would have had to have known to figure row 4 here.
Yeah.
And he didn't tell you to do it. So it's probably just as easy. It's, you know, not that bad to just do all 3 rows directly.
I tried some of everything. I went and I would get close, like however I did it, but it wouldn't be exact and I would get it wrong. I mean, so I was like, I don't know. I watched videos on it from Pearson, you know, anything I could get my hands on. I was like, I don't know. I mean, so I just gave up.
You really have to see these tables, chart it out with these tables to really make it clear.
Okay.
There is one thing I usually do when I'm on my lap. There is on your right hand, you have a tab. There is a tab there that you can click. It says example, view example. So at times when I find it difficult to solve, I go to that tab and I click on it on the one that says view example. So I try to follow the example, what the person did on it, and then I try to come back to solve the problem. That's another way I try to.
So
Yeah.
where do you see the view example? Does it have the little movie strip, the little movie symbol?
It has something like a V dark dot on the right hand where you open each question in my lab. So when you click on it, it gives you options. There are options that there are videos, view examples.
Yeah. I'm in there. Okay.
So I tried.
Tried.
Follow it from that point. Then if I don't get it at all, I bring it to the professor.
Mm-hmm.
Thank you.
Yep, good advice. I find it a lot easier to help students when I'm right there in the math lab or, in the computer screen, and everybody can see everything. But that was obviously pre-COVID, because I remember sitting right beside a student, you didn't think anything about it. You sat right beside a student, you could point at the screen, and try to, help people with it. And you weren't worried about being at least 6 feet away and wearing masks. Golly. I don't know if we'll ever get back to that way.
I don't know either.
Man.
Yeah.
Is there anything else I can help y'all with?
I'm good, Professor.
I'm
Okay,
good.
he's
too.
good, Mr. Augustine. Everybody else good, or y'all want to see something?
I think I'm okay.
Okay. Yeah, look for the next quiz tomorrow over just 6-1 here. And then
Okay.
get chapters. Chapter 7 is going to be a little long and tough next week.
Oh boy.
Yeah.
What's the topic, Professor?
Continuous distributions.
Wow.
And they're done completely different. Basically, we relax. These are all discrete. Well, this is chapter 5 probability, but 6-1 was all discrete, only whole numbers. And so in chapter 7, we relax that.
Okay.
But I think you'll follow it pretty good if you pay attention to the Zooms. We'll try to go 3 Zoom meetings, a week. We'll try to. It should get across. You'll figure it out.
Thank you.
All right, sure thing. Appreciate y'all coming out late on a Thursday night.
Thank you.
Yep, sure thing.
Yes, sir.
Uh-huh. That enough for tonight?
Yes, please.
Yes,
Okay.
good
For
night.
me, yes.
Y'all have a good night.
All right, you too.
Okay,
You too. Thank you.
thank you. Mhm.
Good night.